emails yesterday, or I hope you saw the emails. Canvas apparently has very little space for me to post things on Canvas. So I put one video up, not even a long video, I put one video up, and it's like, you've used 97% of your capacity on Canvas. It's like, great. So I'm working on getting the videos posted. I'm going to have to put them on YouTube, and I'm either going to have to get YouTube verified or like chop them into 15-minute parts for each lecture, which is not ideal.
But aren't they only like 30 minutes?
Well, some of them, like the one I did yesterday, was like almost 45 minutes because I lectured almost the entire class. So
put it on Google Drive.
Well, but if I put it on Google Drive, what I found out from some of y'all yesterday is when you click on it, it takes forever to open, or it doesn't open at all. Like someone clicked on it, he's like, I got to see it, but it took 8 minutes to start playing, which is not acceptable. Yeah. And everything right now is stressed because these are all programs that people barely used before. And now literally every school in the country and every student in the country is using these programs. And so they're really maxed at their capacity. So back on topic, Mercury, the innermost planet, closest to the sun, smallest planet, if you're excluding Pluto. If Pluto was back in, Pluto is definitely smaller than Mercury. There's some weird stuff that's going to go on. So look at this. Mercury revolves around the sun quickly, 88 days. So a year on Mercury is 88 days. But it rotates very slowly on its axis. So a day on Mercury is 176 days. So a day on Mercury is twice as long as a year on Mercury, which is weird. Mercury also has the greatest temperature extremes. These are very extreme temperatures. Negative 173 degrees Celsius, positive 427 degrees Celsius. So remember, in Celsius, the bigger numbers are going to be even bigger in temperatures if they were in Fahrenheit. And the reason for this is there's no atmosphere. And so there's nothing to hold the heat in, and we'll see the opposite of that on Venus, the very next planet. There's no atmosphere, so in the sun, you're very, very hot because you're very, very close, and there's nothing in between you and the sun. On the opposite side, when you're in the shadow and you're facing away from the sun, there's no atmosphere to hold that heat in, and so it all leaves very, very quickly, and you end up going super, super cold. I don't know what the standard temperature of the vacuum of space is, but you're probably not too far away from it. Excuse me. It resembles Earth's moon. It has very low reflectivity, no sustained atmosphere, and some volcanic activity and lots of craters. So we're going to see an image of that. This one's a little bit probably toned down in saturation. What color does Mercury usually kind of look like in the sky?
Yellow.
Like a reddish color, in association with the element Mercury, which has that red color. And I'm not up on my ancient Greek mythology. Mercury is probably like a war god or something. Was it Aries?
Aries is the Greek counterpart to the Roman.
Yes, and that makes it even more complicated because they all have the same like kind of set of people, but the Romans and the Greeks had opposite. Yeah.
Like, Neptune is Poseidon. Zeus is Jupiter.
Yeah. My wife is familiar with all those. But this is a nice little map, and if you weren't super paying attention, this could easily be mistaken for terrain on the moon. Lots of craters, kind of that low reflectivity, not super bright. You can even see some rays where some ejecta has been shot out of the craters. So that's Mercury. Now we move on to Venus, the veiled planet, and they're referring to Venus's super thick atmosphere. So it orbits in a near perfect circle, and I mentioned to y'all the orbits are elliptical, but they're probably closer to a circle than the nice ellipse that we imagine when we say elliptical. A year on Venus is 225 Earth days, so we're getting closer to that Earth year, but not quite. This one rotates in the opposite direction of other planets, and so I kind of have that illustrated here on the board. And we have a couple planets and moons that do things opposite of everything else in the solar system. And when that happens, you know that something kind of catastrophic happened. Venus isn't in the same position that it originally started in, or it would be rotating the same way as more than likely all the other planets. So it's not its orbit around the sun that's opposite. It is the same directional orbit around the sun. What's opposite is its day-night rotation on its axis. And so where Earth is kind of rotating counterclockwise, Venus would be rotating clockwise. Where no other planet does that, that kind of shows you that something happened to Venus to throw it off. Either a planetary impact kind of flipped it over, or maybe a giant planetary impact started its rotation in the opposite direction. At this point, because we weren't there to witness it, it's probably difficult to get an accurate theory on why that happened, but I'm sure if you look it up, you can probably find some interesting ones. Again, rotates very slowly. A Venus day is 244 Earth days, so again, your day is longer than your year. So these things aren't necessarily going super fast in their rotation. And then if you think about it, like we see this as very slow, but if we grew up on Venus instead of Earth, we would look at Earth and be like, wow, that thing's like whipping around super fast. It's got a longer year than us, but it goes all the way around just like in this very short period of time, which we call a day now, but they wouldn't call it a day. So Earth is really like spinning like a top pretty quickly, which is good for us. It helps with the tides. It helps with all sorts of things. Now we get to the atmosphere. It has a very dense atmosphere, 97% carbon dioxide. Is carbon dioxide bad for us? Yes. What's the number one element in our atmosphere? Anybody know? Nitrogen, yeah. We're like 21% oxygen, like 70, not 79, but high 70s% nitrogen and very little of everything else. And so there's an extreme greenhouse effect. We talked about carbon dioxide being a greenhouse gas here. They have the same thing with 97% carbon dioxide. So what that means is your high temperature, which is relatively close to the high temperature on Mercury, it doesn't go away. Day and night, doesn't matter what side of the planet you're on, where the sun's at, it's going to be about 450 degrees Celsius all the time. And that's because of that thick atmosphere holding in all of that heat and not really letting it dissipate in any way. Along with that, the atmosphere has a lot of sulfuric acid in it, which is not great for our machines that we try to land there. I've probably mentioned this. We've not landed anything on Venus. The only country to successfully land anything on Venus has been Russia. They've done it twice, and both times I think they lasted about an hour. And so years and years of work, millions and millions of dollars of design, a long time spent actually getting there and landing, and then you get about an hour of work, and then it's dead. And so Venus is very, very hostile and inhabitable, even to the robots that we create to land there. The composition is probably very similar to Earth, and in fact, I've read a lot of literature about how Venus and Earth are kind of like sister planets. Obviously, they diverged at a certain point, and Venus is now a hellscape where Earth is a nice paradise. But in composition and probably very early setting, Venus and Earth were pretty similar. It does have a weak magnetic field, which results in internal dynamics, which means they have volcanoes. We've identified more than 1,000 volcanoes, which are 20 kilometers wide. We're going to see pictures of them here. This is a little bit of side science. This is a cool picture. It looks nice. This is one of the worst color bars you can do. And the reason is, if you look at the colors, low and high have the same color. That's not a good idea. If you have two different extremes, you want them to be different colors, so it's easy to tell. Looking at this, what are the low parts and what are the high parts? I don't know. You don't know either. I mean, they have it highlighted here as the highlands, but you should have some different colors at the ends of your color bar. We'll see a different one in a second that does that. Here's a picture. This is not taken from the surface. This is probably taken from an orbiter that's able to peer through the thick atmosphere. So here's a volcano, which we use the term Mons for the extraterrestrial volcanoes. Mars has the biggest one, which is Olympus Mons, which we'll get to later. But they have Mont Mons, Sapus Mons, and then you can see some volcanic flows that came out of this volcano right here. So active volcanoes on Venus. Now we get to Mars. Notice we skipped over Earth. We will spend the rest of the semester on Earth. Did you have a question?
No, I was just wrong. Mars is Aries, Mercury is Hermes.
Yeah, Mars is Aries. So Mars is the red planet, fourth planet from the sun, about half the diameter of Earth. They don't say this, but it's about a sixth of the gravity. And so if we ever land people on Mars, they'll be able to work and do stuff pretty nicely because they will have gravity, but it'll be pretty easy to move around, especially in a big, bulky spacesuit. Revolves around the sun, 687 Earth days, so roughly 2 years' time of Earth years for Mars to go all the way around the sun. Surface temperatures range from low -140s at the poles. And remember, this is a little bit more dynamic because it has an atmosphere now. It has an atmosphere, it's further away from the sun, and so you have really cold temperatures at the poles. During the summer, you have really high temperatures, 68 degrees. Doesn't sound high, but remember, this is in Celsius, and so a nice, like, wonderfully comfortable 70 degrees in Fahrenheit, I think is 23, maybe 25 in Celsius. So 68 degrees Celsius is really hot. You wouldn't want to go outside without protection on. A very thin atmosphere, only 1%, but that atmosphere still does stuff. If you watch The Martian, the guy who wrote that did a really good job consulting scientists and understanding the actual science. So it has very big windstorms, lots of dynamic movement in its atmosphere. It's about 95% carbon dioxide, which again is bad. But it does have nitrogen, oxygen, and water vapor, which if you ignore the carbon dioxide, that's pretty similar to Earth's makeup. And so at some point in time, we believe Mars had something similar to what Earth is going on. Here's a nice color bar. I would maybe pick something a little different from this brown, maybe delete this brown and kind of spread everything out a little bit more. But black at the low end, white at the high end, that's a lot better than the other one. A couple things to note here. If we did, so like Elon Musk, probably a supervillain at some point in time, he wants to blow up, he wants to nuke the poles of Mars and melt all the water to kind of kickstart like an atmospheric process, which hopefully no one ever lets him do that. If you were to melt all the water on Mars, you'd have one large ocean and one large continent, not separated out like the Earth where you have lots of different places and lots of different stuff. It'd pretty much be half ocean, not half ocean, it's less than half, and mostly continent. Out in the middle of the ocean here, you'd have I thought that said Olympus Mons. Where's Olympus Mons? There it is. So not in the middle of the ocean, but out in the middle of the ocean, you would have a volcano. This is Olympus Mons, the largest volcano in the solar system. We've not found one larger. We've got an example of how big it is in just a second. So 2/3 of Mars' surface is cratered highlands, which if we melted all the water would be the continent, and you'd have about a third of it would be the ocean. And they kind of mentioned that here. Mars has some of the largest volcanoes in the solar system, including the largest, Olympus Mons. And one of the reasons for that is it doesn't have plate tectonics like we have. So we'll talk about Hawaii later in the semester. But Hawaii is fed from one hotspot. Now, that being said, it's not as big, not anywhere close to as big as this, because that plate moves. And so all of the Hawaiian islands are fed by the same volcanic tube. And in fact, if you look under the ocean, there's a whole chain of islands that stretches all the way to Japan, made by that same volcanic hotspot. And so if it had stayed in the same place for this entire time, we might have a volcano as big as this, but it hasn't, so we have lots and lots of tiny volcanoes strung out over a long distance. The dominant force of erosion is wind. These windstorms are bad. It's really hard for our rovers to survive those. In fact, when we first started landing stuff on Mars, we didn't expect them to last very long. Turns out we over-engineered them, and they've lasted like decades longer than they were intended to. So, poleward of 30 degrees, you do have water ice within 1 meter of the surface. So we know there's water on Mars. We've seen the evidence of it. When we get into rocks, these are clearly sedimentary rocks, formed near a flowing river of water. Once we get there, we might find some evidence that it's not so clear cut. But from the images we have, especially stuff like this, which looks very much like a braided river that you would see here on Earth, there's a lot of evidence to suggest that not only does Mars have water, it used to flow along the surface in ways very similar to what you have here on Earth. Here's a satellite picture of Olympus Mons, the solar system's largest volcano. What state is outlined here for my geography people? No. Poor state.
Arizona.
Poor state. Arizona. It's Arizona here. To be fair, there's a couple states that have great shapes, and you're living in one of them. There's nobody in Arizona is getting like the Arizona state shape tattooed on their arm. I don't know if it's Washington or Oregon. One of the states looks like a slice of bread. I lived next to someone that was from there. I was like, wow, that person really loves bread because they had a. No, it's not Washington. I think it's Oregon. Yeah. And I was like, it had the shape of Oregon and like a heart inside. I was like, man, really love sliced bread. And then I figured out it was Oregon and not bread. So yeah, be glad that you've got a great state shape that you live in. Because others could be a lot less great. I already mentioned why the largest volcanoes on Earth are so much smaller than the largest ones on Mars. It's the plate tectonics. Also, Earth does have a lot of weathering and erosion going on. Not that Mars doesn't have any, but our atmosphere is so much more substantial, and we have flowing water that really helps with the erosion to kind of keep things knocked down. Now, we transition, and I wish maybe one day I'll move the asteroid belt in between Mars and Jupiter, because there's an asteroid belt in between Mars and Jupiter. But we're going to go ahead and move on to the outer gaseous planets, starting with Jupiter. Jupiter's huge. Jupiter's really, really large. If you took all the other stuff in the solar system, minus the sun, all the other planets, all the satellites, all the moons, all the asteroids, put them all together, Jupiter would still be 2.5 times bigger than all of them. Jupiter is super, super massive. It has a huge amount of gravity. If it were only 10 times larger, which sounds large, but that's not that big as far as scale-wise. If it were 10 times larger, it would be a small star. So it's really close to the edge of having internal nuclear fusion to kind of put it into the star class. It rapidly rotates. This, I would think, is somewhat debatable because our ability to see into the depths of Jupiter is limited because of its atmosphere. But on the outside of the atmosphere and what we've guessed, slightly less than 10 hours, which is fast for a planet so large. It's really whipping around there kind of like we are. It has a banded appearance, and I will show you those in a second. But these bands actually correspond to the atmospheric dynamics. So each band is kind of going opposite of each other at the surface. And on top of that, the white bands are material coming up from the bottom, and the dark bands are material going down from the top to replace that. Also, it has the Great Red Spot, which we've all learned about in school multiple times. It's a giant cyclonic hurricane that has existed as long as we've been able to see Jupiter. It's been there doing its thing. One day, it might fall apart and disappear, but we don't know when that's going to happen. For right now, it's like a fixed thing on the planet. So here's a nice illustration. You have winds going this way, winds going that way. You have air circulation coming up, air circulation going down. And so you can very much see the general dynamics of the atmosphere of Jupiter. If you ever get a chance to look through a telescope, you can see these stripes just from a simple telescope that's not that big. And so if you ever go anywhere and someone's like, I got the telescope out, take a look through it. You might see something really, really cool. This is one of Jupiter's moons. I think they're talking about Io in both of these pictures. So it's here on the poster, the closest one to it. It has a lot of volcanoes. It has a lot of volcanic activity, mainly because it's so close to Jupiter and the gravity is always squeezing Io like an accordion. So as it rotates around, it's always being squeezed kind of in the direction of Jupiter, which makes the inside nice and hot and pressurized, which makes it have a lot of volcanoes. So here's a volcanic eruption seen kind of like from over the equator, not the equator, the horizon. And so we can see it being ejected out into space. Here's literally a picture of open lava on the surface of Io, which is pretty sweet to see. So on this, I've read it a couple times now. I'm not 100% sure whether they're talking about Jupiter or one of its moons. I think because of the metallic hydrogen, they're probably talking about Jupiter itself. So it has a surface ocean of liquid hydrogen. Halfway in, the pressure from all of that mass and gravity causes the liquid hydrogen to turn into liquid metallic hydrogen, which is a thing. If you look, remember back to chemistry, hydrogen is over here, and oh, my brain just went blank. What are these metals over here? No, they're not metals. The alkali metals and the alkali earth metals. So hydrogen is an alkali metal. And if you get enough pressure in it, it will turn into a liquid metal. And they've even theorized a solid metal, which would be crazy if we could ever get that. They think it has a rocky core. That's going to be very hard to verify with such an extreme gravity. Lots and lots of moons. With all that gravity, you've got lots of things that get attracted to you and start to orbit. At least 28 moons. The 4 largest ones were discovered by Galileo, one of the first people to perfect a telescope. He didn't invent it, but he perfected it. And so he discovered Callisto, Europa, Ganymede, Io. I think Europa, Ganymede, and Io in one of my favorite book series, The Expanse. People are living on all 3 of these. So pretty interesting that we're all like on all the moons. So here's pictures of each of them. We've sent stuff. We've probably sent stuff to most of the things in the solar system, or gotten close enough to take a pretty decent picture and some readings from them. So they have Io, Europa, Ganymede, Callisto. Then we move on to Saturn. Similar to Jupiter in a lot of different ways, just smaller. Saturn does have the prominent rings, but I will remind you, all 4 of the outer planets have rings. We didn't know about all of them for a very long time, but relatively recently we've discovered that they all have rings. They are the most prominent feature. They were discovered by Galileo in 1610. So again, before he looked through his telescope, we had no clue. Composed of small particle moonlets that orbit the planet, and we'll see in a little bit a picture that describes what I was talking about the other day, where when you have those gaps in the rings, that's because there's a moon there, and that moon has kind of sucked in all the material from the rings and cleared it out with its gravity. Thought to be debris ejected from moons, and I would even argue if you give it long enough, the rings might disappear and become more moons. Gravity's always going to kind of be doing its thing. They appear to be pretty stable right now, but if something gets shoved in there that's big enough, it's going to wipe out those rings and start to collect all the material from them. So that'd be pretty interesting. Yeah, their origin is still being debated. So they show you the gaps here. They have the Cassini division. They named it that because Cassini literally flew through it. They have the Inky Gap, which also has a moon in it. I think they named the moon. Maybe not. We'll see. It might be the Inky Moon. We'll see. And then they have the different ring sections kind of lettered so they can refer to them in meaningful ways. Other features of Saturn, it has a dynamic atmosphere. It does have cyclonic storms similar to the red spot. It has a couple more moons than Jupiter. No, yeah, we're talking about Saturn. A couple more moons than Jupiter. The largest one is Titan, which Titan's a great name for a large moon. It is the 2nd largest moon in the solar system and has a substantial atmosphere. There's lots of science fiction where humans live on Titan in these giant domes because the atmosphere is not good for us. But we live in domes, and the domes look pretty cool because the atmosphere is right outside. So here is, I believe this is Enceladus, which is the 2nd closest moon to Saturn as far as the ones on this poster. There's only 7 on this poster, and there's 30 total, so it may not be the 2nd closest. This is the spot that we think is probably most likely to have life on it in our solar system, if there is life outside of Earth in our solar system. Has a giant ocean underneath this ice covered crust, and we don't even really have to dig down to get to it. It has eruptions pretty often that just spew the ocean water into space. I believe we've had a spacecraft fly through this and sample it. If not, we definitely have that on the back burner until we get something out there again. Here's some of the gaps. You can see the inky gap they have highlighted here, and that tiny little speck is the moon that has created the inky gap. And so it's kind of going around the rings probably at a faster or slower rate than the rest of the rings. And as it goes by, its gravity just pulls everything in and just kind of vacuums this strip up. And so you have these nice gaps. Here's another moon. And you can even see, I think they describe it. It's not the greatest picture, but maybe if you pull it up on your Chromebook and kind of zoom in, you can see some of the material from this ring being pulled towards that moon. And so gravity is very much at play here. Then we get to Uranus and Neptune, the twins. Uranus rotates on its side, which you can kind of see on the poster. They have the rings in a vertical way where the other planets don't really show that. And anytime you have something like that, probably some sort of impact or something strange went on. That's not likely that it formed that way originally. It does have rings, like all of them do. It has a couple large moons. Neptune is very similar with a dynamic atmosphere. Neptune's one of the windiest places in the solar system, and it has a great dark spot. Before we really got out there with our satellites into deep space, we kind of assumed that these would not be that interesting. They're very far away from the sun. They don't have a lot of energy getting to them. We figured they would just be kind of static and boring, and that is very far from the truth. Even Pluto, when we got by Pluto, we thought Pluto would just be like a rock. And there's all sorts of interesting things that we saw on the surface of Pluto. And so, yeah, there's really cool stuff all over the solar system. Neptune has white cirrus-like clouds, which we'll see in a picture in a second. Cirrus-like clouds are like clouds that we have here in our own atmosphere. And so there's a lot of physics at play that show that, similar things happen on all of these planets and Earth included. So Uranus has 5 large moons that have varied terrains. We're not going to get into all of them. The innermost was recently geologically active, meaning it had tectonics and volcanoes and similar things to Earth. Uranus's rings were discovered in 1977, not very long ago. So we knew about Uranus for quite a long time before we knew that it had rings. Those were just 5 of them. More recently than that, we've discovered 5 more. So we know it has at least 10 rings now. Here's a picture of it, nice and like vertical rings, which looks pretty cool. You can see some of the atmospheric dynamics. These are probably similar to like Northern Lights kind of things. I'm not sure exactly what those red spots are. They could be artifacts from the picture. You're taking a picture way out in space. Then they talk a little bit about their moons. Triton, not to be confused with Titan, the largest moon. Triton is the largest Neptunian moon. It orbits opposite all directions of planets, and so they think that it was kind of captured in a different way. Again, anytime something does its thing differently than all the other moons or all the other planets in the solar system, that's something of interest, and you probably have a reason to explain that. It does have the lowest surface temperature in the solar system because it's like one of the furthest away. So it's getting very, very little sunlight. It does have some volcanic activity, largely composed of water ice covered with layers of solid nitrogen and methane. Methane is something that could be of interest to us. If we ever do try to actually leave the solar system or travel around the solar system frequently, methane is a great rocket fuel. So that's a good thing to know. Neptune does have some rings. It has 5 named rings. 2 of them are big, 3 of them are narrow, and they're probably really hard to see without a nice telescope. Here's the clouds that I promised you, cirrus-like clouds, kind of floating around. They have the great dark spot. They have another dark spot with a bright center, and there's people that are trying to work out from a distance what kind of dynamics these are and what these mean for the atmosphere of Neptune. Okay. Why are many of Jupiter's small satellites thought to have been captured? Because of the way they act and how they act differently from the larger moons that Jupiter has. So they're small enough to have been passing comets or asteroids. They're not necessarily big like our moon. and they revolve in the opposite direction and at weird angles than the rest of the moons. And so if you follow the standard way that a solar system or a planet should form, your moon shouldn't be all over the place going crazy. And so even if they weren't captured, they may have been hit by something that was captured and kind of thrown off of their orbit. But Jupiter has an immense amount of gravity, so to think that it didn't pull in, another passing comet or asteroid would be a little silly. It easily could do that. And for a long time, we kind of think, and I think there's a lot of people who still follow this, that Jupiter has protected us in the inner part of the solar system. Just because of its gravity, it's difficult for a lot of things to get by Jupiter and Saturn without kind of getting sucked in. Then we get to the asteroid belt, which is between Mars and Jupiter, a bunch of small, rocky, icy bodies. Some have very eccentric orbits. They come closer to us, and then they go further away. Usually when you have the two Perseid meteor showers, that's a group of these asteroids that come in closer to Earth, and they get kind of caught up in our atmosphere, and you get nice shooting stars a couple times a year. With many recent impacts on the moon and Earth were from collisions with asteroids. Just got unlucky. We happen to be in the same place in the same time. They're not round. They're not big enough to have their own gravity. Well, they have their own gravity, but not enough to make them into a round shape. And their origin varies. We've got ideas about where they come from, but there's so many of them, you can't really put like a blanket statement on it and be like, all the asteroids come from this origin. So here we are, Earth, Mars, Venus, and Mercury inside. You have your asteroid belt, and it's kind of hard to see in this picture, but they have some highlighted orbits where some of these asteroids come way down inside our orbit and then back out. These are the ones we have to be concerned about, because these are the ones that one day we could possibly collide with and could cause problems for us. So we try to identify them. Here's a picture of an elongated one. We're getting pretty good at kind of identifying them and reading them from far distances and understanding their shape and their orbital pattern. Okay, then they get into comets. Know that comets are not rocky for the most part. They are mostly ice. We call them dirty snowballs. Also, the thing I hope you all remember is that the tail of the comet does not point to the way the comet is going. The tail of the comet always points away from the sun. So even if the comet is headed away from the sun, the tail is pointing away from that. And so sometimes the comet tail kind of gives you a direction. Sometimes it's opposite. So you never really know. But the tail is from the sun's rays and energy kind of pushing off that ice, making it evaporate and creating this nice vapor trail. Origin not well known. We have not done a whole bunch with comets. We would like to land on a comet soon and take some samples. The famous short period comet is Halley's Comet, 76-year orbital period. Someone Google Halley's Comet real quick and tell me the next time it's going to come by, because you're probably only going to get to see it once in your life.
2061.
2061. So eat your vegetables, don't smoke or drink, and live to see 2061, and you can see Halley's Comet again. But that's your only chance. A lot of comets are much longer periods than that, hundreds of years, thousands of years, and unless you're born in the right time, you'll never really get to see them. Here's an example of a comet tail. Here's a nice illustration that shows that the comet tail is always pointed away from the sun, no matter which direction the comet is headed. The tail is going to be pointing away from the sun. Then they get into meteors, meteor showers, the Perseid meteor shower. Meteors are mostly rocky and metal. They burn up in our atmosphere. I think maybe at some point we'll talk about the size differences between meteors and asteroids, because there is like a size classification, although it's not necessarily set in stone. It's kind of fluid. This might be at the Space Center in Houston. Meteors are pretty cool. They're pretty rare if you're able to find them. There's people that go out and hunt them with metal detectors. There might even be a TV show about it. And this might be the Arizona crater I mentioned the other day where the guy tried to excavate the center. You can actually, it is, because you can see the road that leads up to it, right up to the crater. So you can go and visit that if you're ever in Arizona. Although most of you don't know what the shape of Arizona looks like, so it might be hard to find on a map. All right, and then we'll end with dwarf planets and Pluto tomorrow, and I will try to have your homework done somehow. Have a nice day. Okay, you want about 3 inches for that? Okay, cool. I will try to get the print started today.
Thank you so much.
No problem, yeah.
We made a big group chat.
Thank you, sir.
This year. And I don't know if you use Snapchat a lot, so like, I was gonna ask.
Oh, I gotta stop my recording.